In this video, we'll have a look at NURBS primitives. And NURBS primitives have a set of controls just like any other set of primitives, but there are some main differences. Since NURBS are dealing with curved surfaces as opposed to polygonal structures or smoothed polygonal structures, there's some differences in the way that these objects are constructed. You can see in the Create Settings section that there are some new and kind of different options here. You can see start sweep and end sweep angles. That's going to be how much it actually revolves around the radius of a sphere. So if I were to do something like start at 0 and end at, I'll just type in 180, I'm actually not going to get a sphere, I'm going to get half a sphere. So let's go ahead and click that in, and there you can see, indeed, I have created half a sphere. Let's go back over and look at some of the options for this. Now, under the Make NURB Sphere 1 tab, here's where we're going to find the initial creation settings that we use. You can see start and end sweep, the radius, which is pretty obvious, just the radius. The next settings down here control how the object is subdivided. You can choose to subdivide it in a cubic or linear way, and that's going to control the faceting here on screen. And you can choose to either manually enter the number of sections and spans, or you can choose to have that done by tolerance. And that's going to mean that essentially, depending on how smooth you want the curve to be, or how smooth each individual patch can be, you can use more or less control patches to define it. So having more curved surface, I can increase the tolerance. It gives me more of a curved surface, and that allows me to decrease the number of sections and spans that are used to create the object. You can see as the tolerance gets lower, that means each individual chunk here can bend less. It takes more and more pieces to define that. So if you are going to be creating something with NURBS, this is a good way of getting an initial starting point and knowing how deep you need to make the object. For most typical beginning modelers, creating NURBS surfaces, you're not going to be creating very, very complex objects with NURBS. So you're going to be looking at things that are usually primitives or close variations of primitives that will be used in your scenes. There are a lot of things that, if you look around a particular scene, are based off of a sphere, a cube, a cylinder, a cone, a plane, and even a torus. So have a look around your environment. I'll bet you can look on your own desktop and find at least half a dozen objects, unless you have an extraordinarily tidy desk, that are based off of, just these basic primitive shapes. So I can actually change this sweep live, and you can watch the object change. And see, since I'm using tolerances, the number of spans is going to dynamically adapt as I draw this out. Now, if I change this and turn off by tolerance, and let's just turn this back up to something like 6 and 6. Now, as I drag this more or less, it's just going to take the amount of sections that we have there and condense more and more or less and less. Now, nice thing about this is all of these attributes are actually keyframeable. So when you want to go into animation, if you need to animate something revolving around like this, and perhaps going from a shape like this to one like this cleanly, then a NURBS object is going to be a prime candidate for this, because you can just animate that sweep. You can animate it coming across, and then if you want, you can even animate it coming back across the other way. So both of those are openly keyframeable. All right, so one thing to keep in mind, though, with NURBS surfaces is that to retain continuity between surfaces, those surfaces are attached. When you want to break continuity for something like a hard edge, then you're actually creating multiple surface patches. So that's going to be the case when we look at most of our other NURBS objects here. So the prime candidate for that is going to be the cube. I'm going to take one and drop in a cube here, and I've already preset this one to have 4x4 divisions, but now you can look and see I actually have 4 independent objects here. So if I take this and move it, you can see it's not attached to the rest of the NURBS object. So creating this kind of non-uniform shape where things are not smoothly curving between each other, it's actually a lot more difficult for NURBS, and so it's actually done by breaking them into multiple pieces. Let's select all that and get rid of it. And you can see that also in the cylinder. So let's go ahead and create a cylinder here. And once again, if I look at this, we're actually looking at 1, 2, 3 chunks. Okay, so these chunks can be useful to get rid of if you just need something open-ended like this. But just remember that as you're editing these objects, this can become cumbersome, because if I'm only, say, selecting this part, and I go to my control vertices and I grab some of these and move them, it's only going to move the top of this cylinder, and it's not going to move the entire thing. So that is just one of the limitations that you have to keep in mind as you're working with NURBS. They do have those limitations, but the smooth surface continuity can make up for that depending on the object that you're actually working with. So that's a quick intro to NURBS objects. All of the different primitives have their own similar sets of controls and constraints. And remember, anytime you see something that is discontinuous, in the cases of something like the cube, the cylinder, and the cone, then you are going to have multiple NURBS patches to actually work with. So if you know that when you get started, it will save you some frustration as you continue moving on. Surfaces that are all continuous, like the sphere and the plane, which is all just one piece, and then the torus will have one kind of revolved surface around, so you actually will have starting and ending points. So you can see, just like with the surface, just so you can see the way that these carry that continuity, the surface of this torus is a revolved surface that wraps around a center point, just like the sphere. So that's just the way NURBS surfaces are made up, and they can be very useful for a lot of operations when creating 3D models.